So as we start now, this is 1.2, defining limits. So for these graphs, it's a simple linear function that's continuous mostly. So we have as x approaches 2, f of x, which is here, approaches 1. So for these, the limit of f of x as x approaches 2 is 1. And then the limit of f of 2 itself is still 1 because it's a continuous line. But as limit of f of x as x approaches 2 is still going to be 1. But this time, f of 2, since there's a hole there, f of 2 does not exist. And for this one, as f of x approaches 2, it's still going to be the same thing. It's going to be f of x is 1. And then this, since it's a hole, it's a jump kind. It's not a hole, it's a jump discontinuity at 3. So f of 2 would be 3. And then for this one right here, we would have the limit of f of x as x approaches 1. So it's all about reading the graph. So as x approaches 1, the limit of f of x is equals to -1. As f of -3 equal to -3, this is where the graph has a little jump down to 0. F of x at x approaches 2 does not, x approaches 2, my fault, is 3. F of 1 does not exist. F of 0 as x approaches 0, f of x is -2. As x approaches -3 on both sides, the limit of f of x is 1. And as f approaches -2, we're gonna have the limit being 2. F of -2, my fault, it's the same thing as the limit in this case. That's gonna be 2, and f of 2 is gonna be 3. Oh, limit is 2, my fault. This is 2. And then given interpretation of limit of x is x7, f of x equals 10. So this would be as x approaches 7, approaches f of x approaches 10. And the limit does not tell us the value of x is, okay, true or false, f of 1 equals to limit of f of 1 equals to limit of x in all cases. This would be false, and then f of 1, that would be true. So that is a wrap up of the basic parts of 1.2.